you, everybody, for coming to talk or coming to this kind of silly talk. So apparently somebody is already hoping that all of my slides are hand-drawn. I can't actually quite fathom that because you can see I have some real artistic ability here. So my talk today is about Rubinius, about poison, potion, and why. And in order for this remote to work, there we go. Okay, so my name is Brian Ford, and I have the pleasure of working with Engine Yard full-time on Rubinius. So pretty awesome job. Engine Yard is quite a cool company in terms of open source. They have sponsored a lot of open source with Rubinius, with JRuby, with Rails, and other projects like Fog, which is an app for managing stuff in the cloud and stuff like that. So I want to thank Engine Yard for all the stuff that they're doing. But also, I want to sort of say that this talk is like you would maybe consider a blog post that I might write that doesn't necessarily reflect the opinions of my employer. So we're partially here to talk about this guy. How many people in this room know who this guy is? Raise your hands if you know who he is. Okay, awesome. So for all you guys that thought this was Jack Black, this is not. This is Black. How many people? I thought the same thing. I have a funny story I'll tell you if we have time. How many people have read Why's Pointing Guide to Ruby? Awesome. How many people sleep with it under their pillow? A couple of people. Awesome. Okay. So earlier in the conference, Dave Thomas was talking to us, and he basically gave us like three sort of ideas, right? One was that he's challenging us to go out and inspire somebody. He's challenging us to diversify, to do something a little bit different than we're used to doing. And he's challenging us to do something new, not just follow in someone else's footsteps, but actually do something new, and actually maybe do it worse instead of thinking that you're always going to do it better. And the reason that I thought that was really interesting is because I think that Y embodied in his work and in his interactions with us, those three ideas, I think he like really embodied it. So Dave Thomas also showed us something here, and what I think like for a possible explanation of where Y might actually be now, I think he's maybe hiding in Dave Thomas's head where he doesn't have any brain. He's like telling him some stuff. So then, yeah, Dave Thomas is channeling Y. So I think, in my experience with Y and looking at his projects, I think that Y struggled with programming. Not that he wasn't a good coder. He wrote some pretty awesome stuff. He wrote stuff like camping, which is a pretty interesting way to think about something. But I think he struggled with the idea of programming, how we interact with programming, how we talk to people about programming, and how we get people excited about programming. And the reason I think that's kind of interesting is because I think a lot of problems that we see, maybe if we think about enterprise software, is that we think that we're doing something that is as serious as launching, something like the space shuttle into space. And I think that's false. Most of our software is not anywhere near that scope, and it doesn't need to be anywhere near that serious. The consequences of something not working is not the same as a space shuttle failing to launch. There's also this idea that our software, the programs that we write have to be super, super good. Like the quality of them is something like, the quality of a BMW M3, right? Also, I think false. I think that is not necessarily the quality of most of our software. I think most of our software is more like this. It has 4 wheels, 2 doors, or whatever. You get in it, you drive somewhere. You get there safely. It's not like this thing is going to fall apart on the road as you're getting there, but it's not meant to go 200 miles an hour. And when we start optimizing our software, it's more like this. And again, not that M3. The other thing is when we think about our languages, especially Ruby, I think Ruby's a fantastic language, but I think mentally we think, our language is something like this super tool 300 that's it's sleek and it's well engineered. And if you were to read that paragraph, it tells you all about how it's strong pliers and designed so it's easy on your hand and all this stuff. But when you look at other industries where people attain high levels of craftsmanship, they don't use Leatherman 300s. In fact, if they use a hammer, they use a very specific hammer for a very specific job. And I mean, there's just a small collection of hammers there. If you've done any construction, you know how important that is. So one of the things, thinking about this general purpose programming language that's just great, it's like your Leatherman 300. Considering how realistic that is I think, a good exercise. Recently, I read this blog. This is a very recent blog post. I think the 6th of November. This is a blog post about toys and sort of considering why are toys quite successful? And it's looking at things like the iPod, which when it first came out, it was sort of considered a toy. There was other stuff out that had better features and more storage and all kinds of crazy stuff. But the iPod became the best-selling music player of all time. In this post, he basically defines this toy as something that is a technological product which is simple and fun to use, and that may be criticized by some people for being weak or not suitable for serious work, right? When you think about how useful the iPod is for what you want to do, play music and enjoyment or entertainment, it is suitable for that serious work. The blog post goes on to sort of talk about 3 areas why he thinks toys are maybe more successful than other serious products. And he basically looks at these 3 areas: user-oriented interfaces or user experience. Like obviously the iPod had really good user experience. It's quite simple to use. The other point that he makes is that sometimes when we're so serious about something, like we're in our business suits and we're doing our enterprise sort of software stuff, not to completely go down the whole enterprises whatever, but the idea that something is really serious, there's 2 things that can happen. One is that people that look at you and see you in your suit automatically attribute to you some greater level of authority than you may necessarily deserve. And that people that are in those roles tend to think of themselves and maybe take themselves more seriously than they should, and then that sort of feeds back and makes them less able to question, am I really doing this well? Is there something I could do better? That sort of thing. And then finally, if it's a toy, meaning that it's probably not as complicated as some serious product, then it may be easier to use. And if it's easier to use, then there's more people that are able to use it, and that's a bigger ecosystem. There's more people using it. There's more people giving feedback. So that was pretty interesting. As an example of something that's not exactly a toy, but really simple, there was this great article about 6 months ago. One of the challenges in world health is easy diagnosis of a condition called anemia, right? If you don't have enough red blood cells in your blood. Unfortunately, in a lot of rural areas, it's very difficult to have this test done because you have to draw blood and send it to a lab, where they have a complex machine that spins very fast and it separates the blood cells in the plasma. A couple of Rice University students made this project where they took a simple salad spinner and they modified it so that you could, with no power, just the pump action of the salad spinner, you can spin this for about 10 minutes and actually get usable results. So this is something that can go out into rural areas in very poor places and actually enable doctors to do diagnosis of this condition so that it can be treated. That was a pretty interesting way to think about something that is potentially really useful, but is very simple. So, what if we did this little thought experiment? Like, I'm pretty sure everybody here is a pretty badass programmer, right? Well, what if you didn't know anything about programming? Why I think this is really interesting, I was at a conference where a Portland State University professor was giving a little lightning talk about teaching Haskell to people who didn't know programming. And I thought, that's pretty crazy. Why in the hell would you start with Haskell? Why would you like try to teach Haskell to somebody who doesn't know anything about programming? So I clarified, I asked, so are you talking about kids here? Are you talking about adults? And he said, no, adults, just people who, you know, have never done any programming. They don't know anything about programming. I'm like, okay. So he took us through a series of sort of simple things that you would do with folks. So starting with values. And I was like, well, do you define what a value is? He's like, no. We assume people can do some basic math. So we just start with values, something like one, you know, an integer, and some simple operations like adding two numbers together. So really simple things. And out of that you have values and you have expressions. And then you add this idea, like what if you took the result of an expression and you gave it a label or a name that then you could use later. So I can set A equal to something, and I can come back and I can use that in the expression for B. So now we have simple values, expressions, and we have variables. And then you think about, well, what if you could, instead of doing the operation right now, maybe save it for later, and at the same time maybe you know, do the operation with different values instead of always having a single value that you have in your expression. So this idea of sort of functions comes out. And then finally you just like think about, well, a few more values. What if you had like a name, and we'll put that in between quotes, and then maybe, you know, try to add them together or call some sort of other function on. So you have these very simple concepts. And if you think about it for a minute, like how much of your programs do these sort of simple things? And also, looking at this, there's no real distinction here between, I mean, we didn't cover conditionals, obviously, right? But there's still no real distinction here between functional programming and regular programming, right? Immutable state, it really doesn't even enter the conversation at that point. So it's really simple introduction. And think about how much you could actually do with these simple constructs, right? So I think that's kind of interesting. Okay, so all that is sort of introduction to why. So why created a programming language? And we're having the little foxes from Point & Guide sort of star in a few of these slides because they've been unemployed for a little while, so they were looking for work. So according to the words I put on here, why made this for people to have more fun. I don't know that. What I do know is that in Y's documentation, he said, in this order, these are the languages that really inspired his work on Pollution. So IO, Ruby, OCaml, Lua, Rebol, and C. Interesting combination of them. But Y already knew Ruby, right? He already knew Ruby, and I'm sure he knew about Lisp and other languages. So there's this sort of thing when you're dealing with Ruby. It's like people learn Ruby and then they want to go learn Haskell, or they want to go learn Clojure, or they want to go learn something else. They want to, you know, have the coolest, most interesting thing. And Y was in this community, and yet he was like, oh, I'm going to play around with the language, and he didn't make it whatever that language is, right? So let's look at some of the stuff that he did put in. This is a little tour of Potion. Okay. So, again, simple values. So you have numbers, you have decimal numbers, you have strings, and there's a couple forms of strings that are really pretty familiar to us. Single quoted strings have only a single escape sequence, and that's the double quote to embed a single quote in a string. Nothing else is sort of processed, everything else is taken literally. And then the double quotes are an escape string where you can actually put a new line character in there. So hello, new line, goodbye. Then there's two basic structured data types. One is the list up at the top. So 1, 2, 3, just put this sequence together. You get a list, put it in parentheses, and you get a list. And then a table, which is a simple associative array, essentially, right? There's a key and a value. Kind of interesting thing is, if you take a list and you put a key and a value in it, it transparently sort of promotes to a table. So underneath, tables and lists are actually pretty similar. And if you know Lua, you know that this idea is not really new. It's kind of convenient. And then, of course, you need functions, right? So those two x equals are sort of two different ways that you can do functions. They don't both exist. One is Y's way, and one is a way that I think I'm going to implement instead. But basically, the idea is that there's no def or anything, right? To make a function, you basically, in the top one, you put a list followed by a colon and some statements and a period. And so anything that starts with a colon, the list is optional, right? It can take no arguments. Anything that starts with a colon and ends with a period is a function, and all of those functions are closures. So they really do close over their state. So if you look at setting a is equal to 5, and then you set y equal to a closure that has just a as a local variable in it, that's going to close over 5 in that outer scope. But it's a super, super simple syntax for that. And then you have like calling methods essentially. So at the top you have a simple table, and we're putting a new entry in it. We're putting an entry named pages with a value of 10, or you have the string hello and you send it the length method message. You can take a number 2, I mean you can take a string 2, turn it into a number, do plus. And then down at the very bottom we have a really interesting construct, ignoring homepage get for a second, where we're setting session equal to URL query. So we're sending query message to URL, whatever the result of that is. There's a question mark at and session. And this is called a query in Potion. And basically what I guess it's pretty similar to what we tried to implement as object try. But basically, if the method exists, it calls it. If it doesn't, you get nil back. But it's a very concise syntax for it. And then conditionals. So conditionals are kind of funny. If we decompose this, we have response equals, okay, so we're just setting a value. If, parenthesis, name equals Ruby, right? And then the colon, blast. This slide is messed up. This is what happens when you write your own slides. Okay, after the grin, grimace, and groan, there's supposed to be a period. So the conditionals are simply an expression in parentheses followed by a code block. So it's very uniform. What's even more interesting is that in Potion, if, else if, and else are actually parsed as message sends. And then the compiler sort of treats them specially and says, oh, you're doing if. Okay, well, so I will evaluate this first thing and then I will call that closure, else if, that sort of thing. They're actually parsed as if they were just simple message sends. And yeah, with the periods, yes?
Can I override them like methods? Like logo or IO?
Yeah, you can't, right, because they're special case. But what you could imagine is what would happen. So, sorry, the question was, can you override them like you can in IO? And you can, because they're special cased in the compiler, right? But the idea is that if you wanted to add something where you could do lazy evaluation, so you could really pass along the condition without evaluating it beforehand, then you could conceivably do something like that. What I think is interesting from a syntax standpoint is that it's very uniform, and there's fewer concepts that you would have to actually describe, right? That's really the key. Finally, creating some classes. So you send the class message to something, and that something in the top is implicit. There's what's called a lobby in Potion, which is like sort of object in Ruby, but if you're familiar with something else like IO, there's actually a lobby instance. So you send that to class, and then you send class to that thing, and you get back a new class. So fruit is a class. And then we can create an instance of it, right? The /color is the way that Potion does instance variables. They're called paths. And the idea is that they're kind of like a path in a file system. to create a subclass, like you see where we're creating apple as a subclass of fruit. Fruit is the receiver of the class message. And to set a instance method on apple, you say apple, the name of the instance method, equals, and then our closure syntax. So it's very concise. The closure that is passed to class is the initialize method, essentially. When it's creating an instance of that class, it runs that bit of code that is passed to class as a closure. And this is in Wise documentation. As I'm reading through the first time I get to that, I'm just like chuckling inside. So I had to add this here. That was Wise is always very dramatic, and even in his HTML, it comes out like that. Okay, so what do we have so far? We have some really simple syntax, some fairly basic ideas. You can create a closure, which is something you can execute later. You can make some values. You have a couple of structured data types, tables and lists. Really, really simple language, right? So when I first started looking at this, my initial reaction after I went through and I started playing with it a little bit was like, God, it's missing this and it's missing that. There's no namespace, there's no modules, there's all this. I'm going to have to do something about this. What can you do with this language? Okay, so I'm going to start implementing Potion, but there's a lot of stuff I'm going to have to fix, right? That was kind of my initial attitude looking at it. So I said, okay, what am I call it? Well, I'll call it Poison because it's like sort of a nasty, nasty potion, right? So that's where the name came from. And initially, the reason I was actually working on this is we're working on a PEG implementation based on the Lua LPEG. And so I was like, what am I going to parse with this? I don't want to parse Python. I don't want to, Perl or something. So I'll play with that language that way. So that's where Poison comes from. I call it an interpretation of Potion, right? Sort of like a singer interprets. If you listen to Latin music, a singer interprets a song. A lot of singers are not songwriters; they interpret someone's song. Okay, and then Rubinius. So of course, what am I going to write this on? Of course, I'm going to write it with Rubinius, right? So Rubinius is a basic. For everybody, I'll give you a super brief introduction. If you want to hear more, you should go to Evan's talk, which was earlier.
Time machine is available in the hallway outside.
Also, it's in your Mac. No. So Rubinius is a bytecode virtual machine. So you can compile to instructions, right? And it's got a modern JIT based on LLVM. It's got a cool garbage collector, and it's got a lot of really cool stuff. And I think it's really healthy for our community. It is not encumbered. It's got a great BSD license. It's not encumbered by anybody. There's no corporation who is going to do anything to you, whether you use it on your mobile phone or on your computer or anywhere else. So we're improving the technology a lot, but it's really interesting, and I think it's a really important thing for our community. So it runs Ruby. That's the fundamental thing about the Rubinius VM, is that it runs Ruby. And why that's important is that there's a number of different VMs out there, and there's actually a project Parrot that you guys probably know of, right? That the idea of Parrot is like you can run any language on this thing, right? The truth is, when you write a virtual machine, you write that virtual machine for one language. The Parrot language is like PCL or something. I mean, like it's a very almost like like assembly language type thing, but that's really the language for the Parrot VM. And there's other languages. There's the JVM, for instance, or other virtual machines. There's a JVM. The JVM language is Java, regardless of what people say. There's some people that would say that you could actually do a lot of stuff on the JVM without touching Java. And what I think is that's very similar to saying you can get in the ocean without getting wet. There's a way to do it. You can get in the ocean without getting wet. You can go down for the waves. But it's not the most useful sort of thing to actually be in that little suit. And when I'm in the ocean, I would rather be enjoying myself. So that's another reason why I think Rubinius is pretty important. So really quick, let's run through how Rubinius actually does something, because if we're going to implement a language on it, we want to know how it works, right? So it starts with source code. You write some Ruby source code. In this case, there's a single class, a single method in that class. And if we put that through the parser, right, we can get back a data structure. In this case, an abstract syntax tree that we have sort of printed out here. Without knowing a lot about the parse yet, we can kind of see stuff that would make sense if we're thinking about it. We ran this on a script. There's a name script, there's the file wise. Stuff kind of like makes sense, right? You look at this for a little bit, you think, oh, okay, that's not too complicated. We can look at it in a different form. If you want to look at it as an S expression, you can actually give the Rubinius compiler the -S switch and see this as an array of arrays, right? And this is essentially what we're looking at. This is just part of the tree. There's obviously more to it, but we're basically looking at an abstract syntax tree. So when Rubinius compiles your code, it starts by parsing it into this data structure. From this data structure, it goes into the compiler. You can run the rbx compile command, and you can give it the -N if you want, and you want to look at just one method. And it'll show you what that abstract syntax tree is compiled down to in instructions. So down there where the numbered things are, 0, 0, 0, 0, 0, 0, 2, that list of things are just a sequence of instructions that the virtual machine is going to execute. Since I don't know what all your backgrounds are, the point of this being really simple is to show you that this is actually really simple. Right? So if you know this, I'm not trying to be pedantic, and I'm not trying to insult your intelligence. If you don't know this, I hope that you see the correlation between some simple data structures, that this is not very hard. Because I want more people to play with this. So if we're going to do a little bit of code like this, so let's make an instance of that class that we had, and we're going to call that method. That method takes a single argument. We're going to pass it rocks, and we expect that it's going to print y rocks, right? But how does it actually do that? The virtual machine, which is a simple stack-based virtual machine, is simply going to execute those instructions one after the other. The IP equals 0, that's the instruction pointer. It's just starting at the index 0 in this array of things, and it's just going to start processing through it. And I've kind of tweaked this a little bit, like where it says push literal y. It would really be looking that up in a table, but that's implementation detail. It could just as easily sort of be there. So we're going to just consider this simple string of instructions, run through it real quick. So IP is 0, basically tells us the virtual machine, go get push literal and do what it says. Well, push literal is going to put something on our stack. So we do it. And now we have the string y on our stack. And then, dang it, there's another error. This is supposed to be push literal, not push. No, I'm sorry. This is correct. Sorry. Blurb is the value that was passed into our function. So we're going to push that value, that local variable, onto the stack. The value that we passed in was the string rocks. And so when we do that, we get rocks. And our stack is growing downward. That's why when we pushed it, you know, there. Allow private is a little instruction that says basically you can find a private method, so we'll sort of go with that. Now what we're going to do is we're going to send a message. The message that we're going to send is 2s, and it takes 0 arguments. So what that's going to do is the receiver is that last element that we pushed in the stack, it's rocks. We're going to send 2s to rocks. It's already a string, so basically what happens when you send 2s to a string, you get the string back. So nothing changes. Now we're going to push the bang. And so now that's what our stack looks like. Last instruction is a special Rubinius instruction. It builds a string out of n elements on the stack, in this case 3. So it's going to build a string out of y, rocks, exclamation point. Puts that back on the stack. The last instruction is to return the way Ruby works, right? When you have a method, the last expression, the result of the last expression is what gets returned, and that's the last thing that's on the stack. So basically, y rocks is returned. Okay. So now we're gonna implement some poison, right? And now the hard part will start, right? Not really, right? It's gonna be the exact same thing. So now we know how Ruby works. We can basically write some implementation of potion or poison. And we're going to do exactly the same thing. Different syntax, but that doesn't really matter, right? We're just going to take a string here, true, we're going to send it the string message, and then the result of that, we're going to send the print message. So we can do the same thing. We can actually look at that syntax in a tree structure like this, or we could look at it in an S expression structure like that. This tree structure, by the way, is using the exact same Rubinius facility that we printed our other AST out. It's just doing it with a different set of nodes, and so we have this tree. It prints it out. And again, you can sort of look at the relationship between an expression like true, string, print, and these messages, like you're sending string, and the value, you're sending it to the value true. So it's fairly easy to see that there's this correlation between the syntax and the structure that you're actually operating on. Okay, so how hard is this to actually do something with? Well, it's pretty simple. Some simple Ruby code. Basically, poison is my top level module. There's a parser thing under it. So what I do, I create an instance of the parser, and I ask it to parse some text, which gives me back this tree. I could print it to an S expression, or I could ask it to graph itself, and I get that tree representation. So still, nothing really that different than we're doing with Ruby already. It's just different syntax, right? Inside the parser, it's not that complicated either. So there's a parse method. You pass it a string, it's going to save that string away. And then it's going to call this method parse string, which as the comment says is actually defined in a C extension. And then if there was a syntax error, it's going to show you that. And otherwise, it's going to pass you back the abstract syntax tree. The C extension itself, this code you probably can't read, but it's not that important because it's like two functions. What we're doing is we're using the Greg parser that Y used in his implementation. It's a PEG parser. It's a modification of Ian Pumarta's PEG leg. It's made to be reentrant, but it's very simple syntax, and it's really, really easy to hook up. I mean, you basically create a little structure. You create an instance of the data structure that the parser needs. You say, hey, go parse some text, and then when it returns, you check and see if it was successful or not. And if it is, then you pass some stuff back. The syntax for the PEG is also really easy. There was also a talk, if you're really interested in PEG, there was an earlier talk as well about, I don't know why they did this schedule, but anyway, you need all your prerequisites before you come to this. Actually, they did it in the correct order. They just didn't tell you that that's what you need. So we're parsing true. So it's an immediate. So an immediate can be a nil or a true or a false, right? And true is just some text. It's just like, literally true, the string, and not something else. The way that the parser is working, if we go back, you see the potion val is true kind. So Y builds this nice little AST using C stuff, and I don't want to do that. So what I do is I just call back into Ruby code. So that potion AST is a really simple callback, and it just calls that method true kind. That method just creates an instance of Boolean, passes it the value true, and that instance of Boolean is just a node in my AST. So it just sort of records the value that it's passed to it. It's a literal. So that's the parser. So now we basically have our AST structure. The compiler is just one little step more than that, right? Basically, I create an instance of the compiler, I give it a string, it parses it behind the scenes, and it compiles it to a poison code object that you can call the method call, right? You can send the method call and it executes. So I'm saying true string print, and when I call on the code that I get back, it prints true. The return value is nil, so that's what we get back. And compile itself is also not very complicated. For compile, what we're doing is basically creating an instance of the Rubinius code generator, and what that is a class that you call methods on, and it collects data as you're calling methods on it into that instruction string that we saw earlier to run. And so we're just setting up a little bit of stuff. We're going to run down that AST, right, using a visitor pattern. We're going to set up some other stuff at the bottom. Basically, we're just going to define directly on an instance of code, poison code. We're going to define the call method, and then we're just going to send that object back. In the AST visit, it's just a simple visitor. So when it gets to the Boolean node calls Boolean on the compiler, and the compiler says if you're true, push true. If you're false, push false. And the way I implemented this, instead of like actually creating a data type for true, I said, well, you know what? What if I just sort of like namespaced some poison methods? So you can do a dynamic symbol. So I just said, hey, I'll call all my poison methods PN : and I already have something that turns true into a string, so I'll just alias to that. Same with string. Instead of like print is functional kind of in Ruby. You call it, you say print, and then what you want printed. But I think it's kind of cool to say string print, send it the print message. So all we do is just sort of flip that around and alias that method again. And so if we look at the code to do true string print, it really comes down to pushing true on the stack, sending that potion string method, which is just an alias to 2s, sending the potion print method, which is just an alias to sort of reverse print, and returns the value. And that's it. That's how easy you can implement a language. So basically what a language is syntax that can be very different. Like the syntax of poison, potion, whatever is quite a bit different than Ruby, but it's going to do very similar things, and the Rubinius VM does those in a sort of, in a sense, generic way with this instruction set, and it's really easy to assemble those instructions and do that, and so off you go. The one idea to sort of contemplate about this is that a lot of people think if you're going to write, like if we're going to have potion on Rubinius, then potion things should be able to talk to Ruby objects transparently, and Ruby objects should be able to talk to potion objects transparently. That's one way you could do it, but there's also another way that you could do it, and that's sort of using the idea of a distinct sort of communication boundary. And if you take something like actors, and you imagine an interface on the potion side, creating an actor and talking over messages to something on the Ruby side that's using actors, you would have to go through far less of that sort of make a potion thing look like a Ruby thing and vice versa. You would just have to worry about the messaging between the two. So when you're thinking about writing your own language, don't like get yourself tied in a knot thinking, oh my God, if I write this language, it's got to like act like Ruby. It's got to respond to Ruby messages and stuff. It doesn't need to do that. There's more than one way to interoperate and actually have really valuable stuff come back to you. So that's just an advisory way. Think about it. So a couple books. I love books. There's a couple books you can use. This book is great. It's a super good introduction to languages, right? It'll take you through parsing, virtual machines, interpreting, how to do that AST, how to walk it, all that stuff. Really good book. If you want to get more serious, this book is fantastic. If you want to get into code generation and sort of understand what happens in a compiler that's generating machine code, this book is super good. And if you want to understand virtual machines, this book it's pretty much the best one that I've seen. There's a couple other virtual machine books out there, but that one's really good. And I'm going to work on this book. Is gonna, I thought slide. Anyway, virtual machines. No. So I won't be doing a learn poison the hard way this way, but Zed has actually put out his sort of template for how you would do a learn X the hard way, and I think that's pretty cool. So yeah, that would be. This is where you can find the code, and there is a website which has got a terrible little placeholder page right now. But if someone has like mad design chops and they want to do like a poison website page for me, there's a URL. And thank you, everyone. I was in RubyConf for a while, and I saw Aaron Patterson give a talk with cross-cultural humor, and he pulled it off really fantastically. And he sort of does this thing sort of almost every morning, like, "Oh my God, good morning, everybody." So I think Aaron Patterson is one of the people that is very much like Y in a playful sense, and sort of keeping us from getting too far into our head, and reminding us that we're human and we like to connect and stuff like that. So thanks to Aaron Patterson, and thank you, everybody.